Now we will start chapter 3, atoms and molecules. Around 500 BC, an Indian philosopher, Maharishi Kannad, postulated that when matter is divided into smaller particles and the smaller particles are further subdivided and continuously being divided into small and small particles, a stage comes when it cannot be further subdivided. He named this smallest particle as Parmanu and matter as Padarth. Another Indian philosopher, Pakudha Katyayama, also suggested that this smallest particle exists in the combined form, due to which various forms of matter are found. Now, around the same era, ancient Greek philosophers Democritus and Leucippus also postulated the same theory, that matter is divided continuously into small and small particles till the smallest particle was obtained which cannot be further subdivided, and he Democritus named this smallest particle as atoms. Atom means indivisible, which cannot be further subdivided. But all these theories were based on philosophy, and there was no experimental evidence put forward to prove this theory. By the end of 18th century, scientists they were interested in knowing the differences between the elements and compounds. They could recognize the difference between elements and compounds, and also they tried to perform activities to study how the elements combine, why do the elements combine, and what happens when the elements combine. Another scientist, Antoine L. Lavoisier, performed a large number of activities and experiments, and then put forward 2 laws of chemical combination. Now, to study the laws of chemical combination, let us first of all perform a very simple activity in the lab. By taking a conical flask fitted with a rubber cork. Now, in this flask is taken a salt solution. Let us say we take sodium chloride solution, and a small ignition tube is taken in which a silver nitrate solution is taken. The ignition tube is suspended in the conical flask very carefully with the help of a thread, so that the 2 solutions do not mix, and then the top is then closed with the help of a cork, so that nothing from outside can be added into the conical flask. Now, this conical flask is very carefully weighed, and the weight is recorded. Then the conical flask is tilted and shaken, so that the 2 solutions can intermix with each other. Now, what will happen? A reaction occurs when these 2 solutions mix with each other, and this instead of clear solution, a milkiness appears, a precipitate forms. Now, when the reaction has occurred, this conical flask is again weighed. What will you find? That there is no change in the weight. Chemical reaction has occurred, but the weight of conical flask has not changed. It means those 2 solutions has reacted, and during a chemical reaction the weight does not change. On the basis of this, Lavoisier gave the law of conservation of mass. Mass can neither be created nor destroyed during a chemical reaction. This we can prove with the help of some more activity. Let us take an example. Let us take a chemical reaction between sodium carbonate and ethanoic acid to give sodium ethanoate, carbon dioxide and water. Now, for the experiment 5.3 grams of sodium carbonate is taken, which reacts with 6 grams of ethanoic acid to form 8.2 grams sodium ethanoate, 2.2 grams carbon dioxide and 0.9 grams water. Now, how can we prove by this data the law of conservation of mass? The mass of the reactants should be equal to the mass of products which have formed after the reaction. So, let us find out the sum of the masses of the sodium carbonate and ethanoic acid by adding, what do we get? By adding this 11.3 grams. And after the reaction, now let us add the masses of all these products formed. What do we get? When we add all these three masses, we get again the same mass, that is 11.3 grams. That is, mass before the reaction is the same as the mass after the reaction has occurred. So, this proves the law of conservation of mass. Now, Lavoisier also found that most of the matter have same elements combined together in the same proportion by mass, and he found that water, from whichever source it is taken, maybe from the spring water, lake water, river water, underground water, or by preparing water by burning of hydrogen in oxygen, it always contained the same elements, hydrogen and oxygen, combined in the same proportion by mass of 1:8. So, in water, what did he find? That hydrogen and oxygen combined together in the same ratio of 1:8 by mass. And same way ammonia, which is formed by the combination of nitrogen and hydrogen, it is found that from whichever source ammonia is collected or from whichever method it is prepared, nitrogen and hydrogen always combined in the same proportion by mass, that is 14:3. Nitrogen and hydrogen always combined in the same proportion by mass 14:3 to form ammonia. So, on the basis of various experiments which he performed, he gave the law of constant proportion, which stated that a chemical compound always consists of same elements combined together in same proportion by mass. Now, let us do some calculation and to prove this law of constant proportion, which is also called law of definite proportion. In water, hydrogen and oxygen combine in the ratio 1:8 by mass. Now, what mass of oxygen will react with 3 grams of hydrogen? Now, we can calculate it with the help of law of constant proportion. So, according to this information which we have, 1 gram hydrogen react with how many grams of oxygen? 8 grams. 8 grams oxygen. So, 3 grams hydrogen will react with 8 into 3 grams, that is 24 grams oxygen. So, on the basis of law of constant proportion, we can also do this calculation. The problem faced by scientists was to provide explanation for these laws of chemical combination, law of conservation of mass and law of constant proportion. British scientist John Dalton picked up the idea and he gave the basic theory of matter. He picked up the idea of divisibility of matter, that matter can be further subdivided, and also he picked up the name atom given by the Greek philosopher Democritus, which was the name given to the smallest particle of matter which cannot be further subdivided. And also he included the theory, the laws of chemical combination, law of conservation of mass and law of constant proportion in his theory. So, now let us discuss the postulates of Dalton's atomic theory. He also stuck to the idea that matter consists of very small tiny particles which are called atoms, and atoms are indivisible, that is they cannot be further subdivided into the smaller particles. Also he said atoms can neither be created nor destroyed based on the law of chemical combination, that is law of conservation of mass. And he also suggested that there are atoms of different elements, and the atoms of same element are identical in all respects, that is atoms of the same element have same mass and same chemical properties. And he said that atoms of different elements have different mass and different chemical properties. And on the basis of law of constant proportion, he included that law also in his theory, that atoms of different elements combine in whole number ratio to form compound. The number and kind of atoms in a compound is fixed, that is the atoms of the same element they combine in a fixed proportion by mass. Also he said that atoms of the same element can combine in more than one ratio to form more than one type of compound, like water and hydrogen peroxide. In hydrogen peroxide, the ratio of hydrogen and oxygen is 2:2, that is 2:32 or 1:16 by mass. So, same elements hydrogen and oxygen combine in different ratio to form different compounds, water and hydrogen peroxide. But there were certain drawbacks in Dalton's atomic theory. So, of course, on the basis of these drawbacks, later on this theory was modified and rejected. The first drawback was that his first postulate that atoms are indivisible, that atoms cannot be further subdivided, and later on it was found that atom can be divided into electron, proton and neutrons. Also, according to Dalton's atomic theory, atoms of same element have same mass, but it was later on found that atoms of the same elements have different masses also, which are called isotopes, like carbon. Carbon has two types of atoms having mass 12 and 14. So, different masses carbon atom has. of 12 also and 14 also. Similarly, hydrogen also has mass equal to 1, mass equal to 2 also, and mass equal to 3 also. Another drawback was that he said that atoms of different elements have different masses, but it was found that atoms of different elements can have same mass also, which are called now isobars. Isobars. For example, potassium and argon have the same mass 40, both have same mass 40 and they are called isobars. So, these are few drawbacks on the basis of which later on Dalton's atomic theory was rejected and later on modified.